Hi everyone, we're back to our statistics class notes. This is now page 28 and we are on example 29. We're in chapter 3 again, which is about numerical summaries of distributions. We're currently talking about the numerical summaries of the symmetric distributions. So we're talking about numerical variables first and foremost, and we're talking about distributions that look symmetric. So something like this, nice and symmetric. Okay. All right, the histogram below represents the percentages of on-time arrivals for various flights over several years. Let's use it to answer the questions that follow, and this is from StatCrunch data that I had. All right, so what is the shape of the distribution? First of all, I'm hoping that you notice that it's fairly symmetric, right? Don't get disturbed by this. It almost looks like a tail. It's not really. Remember, data is not perfect. So when we look at something, if we're questioning in our mind whether it's symmetric or skewed, we should go with symmetric. Okay. Unimodal, one mound, and there's really no outliers here. Nothing that's far away from everything else. What is the typical percentage of on-time arrivals that you see just by looking at the distribution? So if somebody says, what's the typical value of a symmetric distribution? What they're asking for is the mean. Now, since we don't have the exact data here, we can't compute the mean. So what we're going to do is we're going to say, well, where is this balance? And when I'm looking at it, it seems to me that a balance is somewhere in this interval, which notice that these bins are 2.5 wide. So this goes from 75 to 77.5, but remember that 77.5 is not in that bin, it's in the next one. So the mean is likely in somewhere between 75 and 77.5, but not counting 77.5. Example 30, the following histogram, hopefully you recognize right away, is not symmetric. This is very much skewed to the right. Okay, this is actually a histogram showing the distribution of salaries of professional baseball players in 2015. So if you, and I haven't again told you how to compute the mean, but we'll be easily able to do that with StatCrunch. So this is a little cut and paste from StatCrunch where I computed the mean and the median. You can see the mean is $4,301,000 and the median is $1,888,000. So they're quite different, right? Which one represents a more typical value? Okay, now I haven't even talked about the median yet. We're going to talk about that in a bit. The median just means the middle number in your data set. That's all that means. So, but notice that the mean is way over here, 4,301,000. I would not say that that's a typical value. I mean, we got to count there of around 40 people, and then low counts out here. Typical value, looks like around 325 or so, 320, right? Of all baseball players, professional baseball players in 2015 were between 0 and 1 million. Okay, and then you have there's more like around 800 players, so that's not quite to the middle number. The middle number is somewhere in here, which is between 1 million and 2 million. And when StatCrunch computed it, it's actually 1,880,000. Okay, so that's much more a better representation of the typical value in a skewed data set. So it's right skewed, certainly unimodal. No, and it has outliers even to the right. You got some people out here, I believe that was Alex Rodriguez, if you know anything about baseball, making, $32, $33 million a year. So is the mean a good representation of the typical baseball salary for that year? I hope you agree. No, it'll be pulled to the right by the large salaries. The mean is pulled to the right here. It's way over here, where the median over here is a much better representation of a typical value.